So today, 2, 5, 19. Jace, I knew you'd like this problem, right? So today's objective is to find the equation of a parabola from many points. And what we're going to do is use the stat button. We're going to use our stats. And we're going to do the same kind of thing we did before, but it's not going to be the linear regression. It's going to be the quadratic regression, because quadratics is another name for parabolas. Okay, I'll explain the difference, but it's the same thing. Okay, so we will use our quadratic reg, and that's what's in your calculus. So that's going to be the quadratic regression line in our calculator. Okay, so let's go ahead and make a graph of this. So we're going to have ages down here. This is age. These will be my times in seconds. Okay. And we know that there's some age where you should run your best 400, right? So, Jace, when you're in your mid-20s, you'll probably be running 40s, right? But when you're really young, you're little, you're not going to run super fast, right? And of course, when you get old like me, you don't run fast anymore either. So it just happens. But somewhere in the middle, you should have your fastest time, which, if you think about it, might be a quadratic or it might be a parabola. So let's go ahead and graph these. So let's see. I've got to get all the way up to 55. So 10, 20, 30, 40. Let's go by fives. 10, 20, 30, 40, 50, 60, and times, I got to get all the way up to 10, 20, 30, 50, 60, 70, 80, 90. Let's go by tens. 10 second, 20, 30, 40, 50, 60, 70, 80, 90, 100. These are seconds, okay? That's 100 seconds. 110. So 120 is 2 minutes, right? But it's 120 seconds. 130, 140, 150, 160, and 170. Okay, so I'm going to do a scatter plot, and I'm going to do my best to get the points where I want them. So let's see, here's the color I want. Let's see, the first one at 10, a 10-year-old, about 123, maybe right about there, right? 13-year-old, about 105. Maybe there. 15-year-old, 68. Oh, big drop, but then, yeah, that happens. 22-year-old, 55. It's about there. 30-year-old, 61. 41-year-old, maybe 70, right about there, and a 55-year-old, 130, okay. All right. It's a pretty sad-looking parabola, right? And if we're going to go ahead and fit all of those points on there, it's going to be difficult to get them on, but, you know, whatever parabola we draw on here probably won't go through all the points, correct? Probably won't. But it's definitely a parabola. We'll find a correlation coefficient. We'll find out how good our fit is. So what we want to do is grab our calculators, right? And let's put the data in. Okay, so let's go to Stat. We're going to go to Edit, right? I'm going to clear out my old data. Clear out my old data. And I'll put the ages in for the list 1, or the x values, right? 10, 13, 15, 22, 30, 41, 55, and times 123, 105, 68, 55, 61, 70, and 130. Okay, how am I doing? I'll let you guys catch up, put them all in, okay? Okay, so then we're going to go back to stat, right? So we're doing the exact same steps we did before, except for it's just a quadratic regression. So we go over to calculate, and then what I'm looking for is number 5. I'm looking for the quadratic regression line, okay? So go down to 5, which is quad reg. Push enter, and I'm going to go all the way down to calculate, okay? And enter, and there it is, okay? And I get an r squared. I don't get an r. That's interesting. Well, r squared's no problem because we can make it into an r. Not a great fit, okay? It's not, but it's going to work, okay? So then here's what I have. I need a y equals ax squared plus bx plus c, right? And in my calculator, it tells me a, b, and c. So let's try and round as much as we can without losing accuracy. So I'll probably go 0.047. So y equals a 0.04. Yeah.
I think everybody got something different.
Well, okay, let's double check. Thank you.
Yeah.
Okay, what do you see? 10, oh, I got 123 right there. That was a bad R. I thought, why is that R so bad? Thank you, Saul. Let's check this out. I had 12 there and 123, and that would mess up my whole thing. Let's go back. Thanks, Saul. Always question me, right? I make mistakes, don't I? How is that? Is that better? 0.1. Did you guys get that one?
Yeah.
Okay, there you go. Merge. Okay, so I've got y equals a 0.14. You okay with around 0.14 x squared minus 8.65x plus 185.8. Okay. My r squared, I got an r squared is 0.87826. So if I need an r, I'll just square root that. It gave me an r squared, it didn't give me an r. But to find r, I'll just take the square root of that. So quit. Go the square root of 0.87826. And I got about a 0.93, which is not a bad correlation coefficient. 0.937. Okay, so one more time, so you don't get confused on this. I go back to stat, calculate, right? And if you didn't get an r, if you're not getting an r squared, let me know, and I will help you get the r squared. Okay, you just have to go into catalog, into diagnosis, and turn it on. Okay, so let me show you real quickly. So it did not give me an r squared, but that's, or it didn't give me an r, but that's okay. It gave me an r squared, and I wrote it down and I square rooted it because I like the r better than the r squared. Okay, it shows me that I get a r of 0.937. That's not bad. It means that most of my points fit, okay? So then, I'm going to do one more thing. We don't use Logger Pro in here, but we don't need Logger Pro because I'm going to show you what we can do, okay? So now, let's put this on our calculator with the line. Okay, and I'll go through this slowly with you, okay? So, what I want you to do is go first y equals. Let's go to y equals because I want to graph this. I want to graph this. Y equals, and we're going to go a 0.14 x squared minus 8.65 x plus 185.8. Okay. Now, before I graph it, I'm going to fix my window. Okay, I'm going to fix my window. So go to Window. Okay, go to your window. Window's right here. And what I really like is to make my window fit my graph, right? Why not make my window fit my graph? So I know this is a good graph because all my points are on there. So I go to my window. Let's make my window fit my graph. So I'm going to go from 0 to 60, okay? So on my x, I'll go from 0 to 60. Does that make sense? Why not use this graph? Because I know all my points fit on that graph, right? I went scales by 5. See the scales? I went by 5s, right? And on my y's, I went from 0 to 170. And I went my scales by 10, okay? So now my window is exactly like my graph, correct? So when I graph it, I should see it, okay? So then I go graph, and there's my parabola, okay? Not bad. Not bad, okay? Am I going too fast? Okay. Now, what I'd like to do is put my points on this to find out how good my points work, okay? So, this is easy to do. So, I'm going to go to my scatter plot, because this is scatter plot, right? Agree? So, I have in blue, you guys see in blue where my pin is?
Yeah.
Scatter plot. So, I'm going to go second scatter plot. And all I have to do is just turn it on. Okay, right now it's off. As soon as I turn it on, it'll show the points on my graph. Okay, so I go and I push enter. Enter. So the scattered plots can do a lot of things. I just want a dot, dot, dot. So I see the dot, 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 dot. Okay, I don't need any of these fancy things. So turn it on. Make sure you have it on. Plot 1 on. See the dot, dot, dot thing should be there, right? That kind of mark, right? List 1, list 2, okay? Everybody got that? So it's a scatter plot. I turned it on. I have to make sure it's a dot-to-dot graph, not any of these weird ones. List 1, list 2, and I'm using these dots, okay? Now if I push enter, if I push graph right now, there's my dots. Isn't that cool? So it's not a bad fit. Now if you're having trouble with this, I can help you with this, okay? Anybody need help with this? Okay, you ready? So let's type. Okay. Get an X in there? Yeah. Minus 5x.
Really good. They're pretty good.
Okay, everybody got it? Now, how about this last piece? So the fastest time at what age? So if I look at my graph, according to this, you can go faster, okay, right? There's a faster time. If I look at my graph, there could be a faster time, correct? And obviously this point is called what's this point called? Starts with a V, yeah, vertex, right? So we need to find the vertex, okay? So if I'm going to find the vertex, it's in standard form. I'm going to use my negative b over 2a, okay? And that'll give me the x value, but the x value is an age. Does that make sense? That will give me the age. That will give me an age. So it'll tell me at what age will Jace run his best 400, okay? So let's take a look at this, okay? So we're going to go a negative 8.65. Let's go on negative b, right? Over 2 times 8.14, okay? So I'm going to go I'm a calculator, let it go. I'll go positive 8.65 divided by 0.28. Okay, is it okay, 0.28?
Yeah.
0.28. So when Jace is about 31 years old, he's going to run his best 400. Okay, there you go, Jace. And which is pretty close to true, but that means those guys are still running at 31, right? So we get an age of about 31 years old, best age. And what's the time? How fast would a 31-year-old run?
Yeah.
How do you find that out?
Well,
It doesn't make sense though, because it says that the age 30 up there
yeah, it's slower
is,
than 22.
slower than
Right.
22.
Right, I'm with you. Totally agree. However, this is just random people off the street. So if I were to sketch this, wouldn't it go a little bit more down like this? Do you see what I'm doing, Saul?
Oh yeah.
See how that works? And these are just random people off the street. Maybe I would have picked somebody better. Maybe I would grab Jace when he was 30, right? I got some better data, right? I mean, yeah, just grab kids off the street and put them on the track and make them run, right? So how good is my data? Well, according to this data, if I had snaked a 31-year-old, Saul, if I grabbed a 31-year-old who hadn't quit working out at after high school, right? I kept working out. I would have got a stud, and we could have had some better times, right? I agree with you. But if you look at the graph, if you try and trace it, it might look more like So does that make more sense if I complete the graph more as a parabola, right? Okay, so then one more question, okay? So 31 years old should be the prime age if I were to get a larger sample, right? A much larger sample. But what would be that time? I got the age. How do I find the time? Who say that again? Plug it in, right? And that's next value, right? So plug it in. Thanks, Rory. So we're going to go y equals a 0.14 times 31 squared minus 8.65 times 31 plus 185.8. Okay. And I'm going to plug it in. Quit. So I'll just let my calculator do the work. You guys agree? I'm just going to go my 0.14 parentheses 31 squared minus 8.65 times 31 plus 185.8. Hit enter. And about a 52.2. There you go, Jace. Okay. That's right. You would have beat that kid, huh? Okay. Let's look at our journal real quickly. I want to make sure we hit that too.